Hi, welcome to this Blender video tutorial entitled Rigid Bodies Part 7 Examples. This is the seventh in a series of video tutorials concerning Blender's rigid body dynamics. In previous video tutorials, we looked at Blender's rigid body dynamics functionality. Here I plan to demonstrate a few rigid body dynamics examples. In this first example, MarbleRoll01.blend, I have modeled a circular spring-shaped track. This was developed from a NURBS surface circle with a screw modifier. I'll play the simulation. The circular track and floor plane are passive rigid bodies, and the multicolored marble and the three cylinder objects are active rigid body objects. I will stop the simulation, and I'll open up the second example, MarbleRoll02.blend. Here are two bent tube-like objects, two colored marble objects, and a bowl. I'll play the simulation. The active rigid body marbles fall into the passive rigid body tubes, and their downward movement is constrained by the shape of the tube. Upon exiting the tubes, they fall into the passive rigid body bowl object. I'll stop the simulation. The red and blue tubes have a semi-transparent material applied to them. When rendered, the animation looks like this. I will close this video and open up the third example, BongBong.blend. Here is a rectangular structure with a center crossbar that is a passive rigid body. At the center of this crossbar and extending outwards are two very thin cylinder objects that are modeled to terminate in a sphere. These objects are active rigid bodies with their bounciness set to 1. I'll go to wireframe view. Each of these objects are constrained to the crossbar object using a rigid body hinge constraint. The control empty for each has been rotated so that its z-axis is parallel to the crossbar object. I'll go back to solid shading display, and I'll play the simulation. The two cylinder sphere objects fall due to gravity, but produce a hinge effect because of the hinge constraint to the crossbar. The bounciness setting of the cylinder spheres causes the objects to bounce away from each other upon collision, yet their movement is constrained by the hinge constraint. I'll stop the simulation and open up the next example, Pivot.blend. Here is a similar structure. I'll switch to wireframe view so you can visualize this better. Here the crossbar and the cylinder spheres are all one active object. At the sphere ends of this object are two small cube objects set to active rigid bodies. The cube objects are attached to the center unit with fixed rigid body constraints. The center unit is attached to the two outside passive cylinder objects using rigid body hinge constraints, one on each end of the crossbar. The control empty for these hinge constraints are rotated so that their z-axis is parallel to the crossbar unit. I'll go back to solid shading mode and play the simulation. In its current state, nothing happens. The mass on one side of the hinge points is equal to the mass on the other side of the hinge points. I'll stop the simulation and go to frame number 1. I'll select the left cube and change its mass setting in the physics panel to 20. I'll then play the simulation. Because one side now has more mass than the other, that side pivots down along the z-axis, but is constrained by the hinge constraints. I'll stop the simulation and go back to frame number 1. I'll set the mass for this cube back to 1. I'll then add layer number 2 to the scene. Here are two additional cube objects located directly above the blue cube. One is fairly close, and the other is much farther up. I will select the lower of these two cubes and make it an active element and set its mass at 20. I'll select the upper cube and make it an active element and set its mass to 20. I'll then play the simulation. The first cube falls colliding with the fixed constraint blue cube, causing the center unit to rotate completely around its hinged constraint. The second cube falls colliding with the fixed constraint red cube, causing the center unit to rotate about its hinged constraint even faster. I'll stop the simulation and open up the next example, cup.blend. I'll switch to wireframe display. Here I have modeled a cup that consists of two active rigid body objects, the cup and the handle. The handle object includes some irregular faces around its juncture with the cup. The cup and handle objects are connected with a rigid body fixed constraint. The fixed constraint control empty has its breakable box checked, and the breaking threshold is set to 2. I'll go to solid shading display, and I'll play the simulation. The cup falls down along the z-axis, and the collision with the passive plane object is strong enough to break the fixed constraint holding the cup and handle together. I'll stop the simulation and open up the next example, car.blend. I'll play the simulation. The car object rolls down the ramp, going over a few bumps, crashes into a barrier, and falls off the ramp. I'll stop the simulation and go to frame number 1. The ramp and barrier are a simple inclined plane set as a passive rigid body element with its bounciness set to 1. The challenge here is to allow the car wheels to rotate, yet keep the car unit whole and acting together as one unit. I'll go to wireframe mode. The car unit consists of 3 active rigid body objects: the car body, the front wheel assembly, and the rear wheel assembly. The wheel assemblies are connected to the car body using rigid body hinge constraints. The control empty for these constraints has been rotated so that its z-axis is parallel to the car body and the wheel shaft. The control empties are located in the center or origin point of the wheel assembly geometry. Note also that the front wheel assembly control empty has its positive z-axis pointing in one direction, and the rear wheel assembly control empty has its positive z-axis pointing in the opposite direction. The wheel assemblies also have a bounciness of 0.6. I'll go back to solid shading mode, and I'll play the simulation. I'll stop the simulation. All of these .blend files, along with the jax.blend file used in the previous video tutorial, are available on our Blender course site in a Lesson 14 file named RigidBodyExamples.zip.